You know that you can get matter either as a solid, and that's when the particles are very close together, or as a liquid where they're pretty close together and at the bottom of the container, or as a gas where they're very far apart. If the particles are very, very far apart, then there are no forces of attraction between them. So in a gas, you don't have to worry about what holds molecules together. But in what are known as the two condensed phases of matter, the particles are close together and somehow they must be attracted to one another. Now, molecules are individual units. So if I take something like water, when I think of it sticking to another water, I have to think of the one water being one unit and the next water being the next unit. And what is it that holds those two units together? So molecules are individual units. When they form a solid, they need to be held together by something called an intermolecular force in between molecules. These forces are very weak forces, and they were first described by a chap by the name of van der Waal, and they are known as van der Waals forces. The stronger the intermolecular force is, the tighter these two things hold onto each other, the higher the melting and boiling points will be. The melting and boiling points are not linked to bonds, they are linked to intermolecular forces. So the first intermolecular force that we can consider is between polar covalent molecules. An example of a polar covalent molecule is HCl. With that HCl, the chlorine is slightly negative, the hydrogen is slightly positive, and another name for this we've talked about before is a dipole. So when two dipoles attract one another, as is the case when one hydrogen chloride is attracted to another hydrogen chloride, we call that type of intermolecular force a dipole-dipole intermolecular force, because two dipoles are hanging on to each other. How are they doing that? It is an electrostatic force of attraction. And that electrostatic force of attraction is between the slightly negative side of the one dipole and the slightly positive side of the other dipole. Ion-dipole intermolecular forces are when you have an ionic substance, let's say sodium chloride, dissolving in water, let's say H2O. Water is a dipole. Sodium chloride is ionic. And therefore, when they are together in the liquid phase, something has to hold on. The slightly positive side of the polar molecule, or the dipole, hangs on to the negative anions, and the slightly negative side of the dipole hangs on to the positive cations. When an ionic solute is dissolved in a polar covalent solvent, we get this ion-dipole intermolecular force. It increases the boiling point because this is quite a strong force of attraction. And the forces of attraction are between slightly positive and negative, and slightly negative and positive. If you take a look, you can see here, if I had a sodium chloride lattice and I put it into water, what happens is all the water molecules orientate themselves with their slightly positive hydrogens facing the chloride ion, and they're slightly, these are all chloride ions, and they're slightly positive, at least negative oxygens facing the positive sodium ion. And so around each sodium ion, the oxygens orientate themselves closer to the sodium, and around each chloride ion, the hydrogens orientate themselves closer to the chloride, negative chloride ion.
When an ionic substance, such as sodium chloride, is placed in water, water molecules interact with the ions on the surface. If the salt is soluble, the attractive interactions with water molecules overcome the ionic attractions within the lattice. The solvated ions move off the surface and become separated in solution. Notice that water molecules cluster about the anions with the hydrogens directed toward the negatively charged ion. On On the other hand, water molecules interact with the positively charged cations through the lone pairs of electrons on the oxygens.
The next type of intermolecular force that we're going to describe is called a London force. It's got lots of synonyms. Sometimes it's called a momentary dipole because the dipole only exists for a moment. Sometimes it's called an instantaneous dipole because the dipole only exists for an instant. Sometimes it's called a snapshot dipole because it's quick. And sometimes it's called an induced dipole because one of the elements causes something else to have another dipole. London forces very, very importantly exist between non-polar covalent molecules. So in other words, how does one oxygen hang on to the next oxygen? They're both non-polar. How come these two would get attracted to each other? The truth is they're not attracted very easily because most of the time they're a gas. But if you bring the temperature down low enough, they will be attracted to each other to form something like solid oxygen. What is that force called? It is a London force or a momentary dipole, instantaneous dipole, snapshot dipole, or induced dipole. These are very, 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 very weak, and they result because of something called an electron cloud shift. And that is a very short-term polarity. So for a short while, the molecule becomes polar, and we call that an electron orbital wobble. Now, if for a split second this side of the oxygen is slightly positive, this side slightly negative, this side will become slightly positive, and this will become slightly negative, just for an instant or for a snapshot or for a moment, that happens and this force of attraction comes into existence. As the electrons move around, you find that changes quite regularly, and without any difficulty at all, it could be the other way around.
Electrons in an atom are in constant motion, but at some point in time there are more electrons on one side, creating delta negative and delta positive
charges on both sides. So this side now, just for a split second, was slightly negative. This side becomes slightly positive, this side becomes slightly negative, and this side becomes slightly positive, and you result in a London force being in the middle over there, which is a very weak electrostatic force. What is this between? One neon atom and another neon atom. Remember, the noble gases do not bond, but if they're a solid, they need to somehow be attracted to each other, and they are attracted to each other by a London force because of this electron cloud wobble.